My name is Todd Capson. I work with it's an organization called Sustainable Fisheries Partnership, and basically in New Zealand for two reasons. One is the State Department invited me to come and to raise awareness about Secretary Kerry's new oceans agenda. There was a meeting held 16th and 17th of June called Our Oceans, and part of it, well, the State Department has a long-standing interest in oceans issues. As part of the Bureau, there's a Bureau of Oceans, Environment, and Science. The Bureau of Ocean, Environment, and Science has two offices, which are exclusively directed to oceans issues. And but Secretary Kerry, in particular, is keen on ocean protection. It's just this personal interest of his. And there were three pillars of this meeting. But in mentioning these three pillars, by no means should these be seen as exclusive. Like if you have a pet project that you're interested in promoting, if it doesn't fall under one of those three, it doesn't mean they're not interested in promoting it. So, for example, President Obama announced the creation of this huge marine protected area in the Pacific Ocean, which didn't specifically fit under one of those pillars, but it's close enough. Nevertheless, they wanted to have some structure for the meeting, which is understandable. And so the three pillars are sustainable fisheries. The second was marine pollution, and marine pollution entails marine debris, or plastics, as well as nutrient pollution, in particular nitrogen and phosphorus effluent that can trigger algal blooms. And the third was ocean acidification. And my own personal involvement, where I first started working with the State Department as I was a diplomacy fellow from 2008 to 2010, and I worked in the two offices dealing with marine issues. At that point, I worked on fisheries, primarily shark conservation in the eastern Pacific Ocean, and on ocean acidification, when I was on the interagency working group for ocean acidification, which came up with the U.S. government's approach, strategy for research and monitoring of that phenomenon. So I was, fortunately, what I worked on aligned well with the priorities of the State Department, and I was fortunate that it is a great deal. I would say the same thing if I weren't accompanied by a State Department colleague. It's just really, it's a fantastic opportunity. And also, obviously I love the oceans like I'm sure everyone else does, so how could I not jump at the chance to come back to New Zealand and promote that agenda? So that's part of the visit, is just to raise awareness about the State Department's oceans agenda. The second part is I've been working over the past almost 2 years now with a number of people in New Zealand, in particular NIWA, MPI, MBIE, and Cawthron Institute and the shellfish aquaculture industry to raise awareness about the need to monitor ocean acidification in coastal environments. You hear a lot about ocean acidification, but often they're in the context of open ocean. So, for example, what's happened globally to the oceans, we have a pretty good idea that pH has dropped by about 0.1 units, which translate to about a 30% increase in acidity. But where it's much more complicated are coastal environments, of course, where people live and make their livelihoods. And in the U.S. and the Pacific Northwest, ocean acidification reared its ugly head about 2008, and it caused shellfish hatcheries to go out of business, lost 80% of their production. The reason it happened is, like most environmental issues, it's not a single cause, but it has to do with their dependence upon larval seed, shellfish larvae that underpin all of shellfish aquaculture in the Pacific Northwest. There are hatcheries where they grow up seeds, and they will sell those seeds to a farmer. The farmer will set those seeds and go and collect a live oyster a few years later. So part of it was that dependence on larvae, and it turns out the shellfish larvae are exquisitely sensitive to ocean acidification, because ocean acidification removes carbonate, and carbonate is half of calcium carbonate, which is what they use to make their shells with. And the other reason it showed up there is because the oceanographic characteristics of the Pacific Northwest. The California current is this huge, they call it an eastern boundary upwelling ecosystem. It carries CO2, but our CO2, in particular emissions from 50 years ago, were downwelled off the coast of Japan, traverse along the bottom of the ocean, run into the west coast of the U.S., and when they're upwelled, they're enriched in CO2. But again, the point is, it's our CO2 that it's enriched with, from whatever source it comes from. So the vulnerability of shellfish larvae, the dependence of the aquaculture on that shellfish larvae for their shellfish aquaculture industry, and oceanographic characteristics kind of combined for the perfect storm, and they lost all their production. But another reason that was telling is because some of us we see the Keeling curve that shows gradual increases in CO2 since the beginning of the Industrial Revolution. I mean, it almost makes us think that we have time to deal with this. And there it was almost like somebody flipped a switch. Granted, it took a year or so it wasn't like 1 minute to the next, but it's starting around 2007 is when they lost all their production. And so, there was nothing gradual. They exceeded that biological threshold, and that was the end of the story. They were able to, the bright side of it is once they started monitoring ocean acidification, they were able to adapt. They chose the time when to fill their tanks, they treat the water, and they were able to restore most of their production. So if you do have a rigorous system of monitoring ocean chemistry, you can, at least in some cases, come up with an adaptation strategy. So now, how does that relate to New Zealand? As you probably know, the shellfish aquaculture industry is heavily dependent upon the Greenland mussel and Pacific oyster. So it made sense, even though the oceanographic characteristics are different in New Zealand, there's interest in future-proofing that industry to changing ocean chemistry, and that's really what brought us all together last December. And it was a consortium. Number one, it's U.S., New Zealand, but it's really a partnership between industry, science, and government. Because like any complex environmental issue, there's no silver bullet, no simple solution. So the only way you can hope to address it is through a partnership of some sort. So we put on that workshop in December, and we're now exploring the next steps, both within New Zealand and also the notion of using New Zealand as a platform to provide training opportunities for countries, Pacific Island countries that are also likely to be impacted by ocean acidification in the future. So set up, because it's not, on the one hand, ocean acidification is very straightforward. It's chemistry. CO2 removes carbonate. That's chemistry 101. On the other hand, measuring the phenomenon is not so simple. And but on the other hand, it creates opportunities for training students. So we're exploring where to go, the next steps. I'm happy to provide details about that if you're